Okay, in this video we're going to look at the Saturn ring system, and the thing here that is important to note is that it is in fact a system of rings. It's not one ring. There are several rings that basically extend outward from the planet. So what are the rings made of is a question that people are very interested in sometimes, and it turns out that the rings are generally made up of water ice. Water ice, of course, being the frozen form of water. And when we consider the size, it widely varies. It ranges in size from fractions of a millimeter, so smaller than a grain of sand, to tens of meters. That would be, maybe something like the size of an airplane. It's filled with particles of ice. It's got other things in it, but it's predominantly made of ice. And that's what makes the ring. That's what the rings are made up of. Now, question is, why do rings form? And you might remember we talked about the Earth's moon and how there was this great impact from this Mars-sized body, and it created this giant debris field and threw it out, and that debris field formed into the moon. Well, if that debris field were closer to the Earth when it was thrown out, it wouldn't have formed into a moon. It would have formed into a ring because the tidal forces of the Earth would have prevented it from forming into a moon. So this is basically the idea. If you have a planet, there is this sort of region, and inside this region you cannot form moons, and outside the region you can. And what happens is the tidal force of the planet will just prevent the moons from forming, but it will sort of spread the debris out and make it form into sort of this ring shape that we see. Now, we've talked about how Jupiter has a ring. Saturn's rings are much more complicated, much more large, much more visible. But all the gas giants in our solar system have rings, so this is something that's actually common is for planets to have rings. But Saturn's rings are, of course, by far, the most spectacular. Now, in your textbook, I've pointed out some of the pictures that I really just love and the reasons why I love them. And this is one of the pictures that I just love because it really just shows how big the rings are. Here we see the Earth, and this is, a accurate size comparison of the Earth to the rings. And you can see that the width of the Earth here, you could fit several of the Earths, line them up, and you wouldn't even go all the way across the rings. So it's huge how big the ring systems are. However, what's interesting is that they're also incredibly thin. I mean, about the height of a one or a two-story house, that's how thin the rings are. So, in one sense, they're gigantically large, and in another sense, they're very, very small. Here is an image showing the fainter rings, and the way that you can see them is by having them be backlit. In other words, the sun is on the other side, and so that the sunlight's shining through, and that makes the rings more visible. In this inset picture here, you can see Enceladus, which is one of Saturn's moons. So these outer rings are also the result of a resonance phenomenon. But what's really interesting to me is the existence of what are called shepherd moons. And Saturn has the shepherd moon as part of the ring system. And the reason it's called a shepherd moon is because of it's sort of its function. On Earth, what do shepherds do? They keep the flock together. They keep the flock from sort of flying off in errant directions. Well, the shepherd moon, its gravity kind of keeps the shape of the rings intact. So here we see an image of the F ring, and as we look, we can see this region here, this inset is blown up, and we can see this ring that is next to the shepherd moon. And as this moon goes along with the ring system, as it goes around Saturn, its gravity kind of helps keep the rings aligned. Now, the next thing that we want to talk about is the way that the rings formed. And the truth is, we don't really know. We don't know how long they've been here. We don't know how long they're going to last. We don't know if the rings are the same age or different ages. We don't know if they were built up slowly or if they're the result of a single catastrophic event, like something smashing into the planet, the way that our moon was formed. We just weren't here to watch, so we don't know. But it is really interesting. Now, one of the things that I just want to mention at the end is that people wonder sometimes what would happen if, an asteroid or a meteor were to strike into the rings. Would they like mess the rings up? And the rings are moving around the planet at very, very high speed. And it's all these particles. It's like, if an asteroid came in, it would go into a blender because the particles would just act like a shotgun and shred it. So, and in this process, as things get attracted to the rings, uh, basically they get broken up by the things moving in the rings and could become part of the rings themselves as well. And so that may be a process by which the rings replenish themselves. But either way, that is some of the things that we know about the ring system, which I think is what makes Saturn uh, really, really interesting.